Hey, last week you started learning about probability, and last week you learned that we could find the probability of something. So, for example, let's say what's the probability of rolling a 4 on a dice? Okay, well, a dice has 6 sides, so if we're going to make our probability fraction, we need the part we care about on top, the total on the bottom. Well, on a dice, how many sides have the number 4? One side, and I'm talking about a normal 6-sided die. So one side has that number. So there's one side we're really hoping gets rolled, but there are a total of 6 sides that could be rolled. That's how we found a probability. We could change that into a decimal or a percent also by dividing top divided by bottom. Now, this is actually called a theoretical probability. It really means that in theory, we think that every 6 times that you roll the dice, you should get the number 4 once. That's in theory, right? A die is normal and you should have an equal chance of getting every single number. That's the theory. In reality, though, we know that doesn't actually happen. Every 6 times you roll, you're not for sure going to get the number 4. So what I'm going to show you today is called experimental probability, where we're hoping for 1 in 6, right? That's what we think it should be, is 1 in 6. But in reality, it might not actually be. So the reason it looks a little bit different back here is I actually am going to show you this. I have this really nice big dice right here that some of you may have seen. It's the one that's been sitting up on top of my cabinets by the door for the whole year. I didn't make it. I have no idea who did, but someone did, and it made its way to my room. So we're going to use it today. So I'm going to roll this huge dice, and up here is the top. So even though you guys can see this front pretty well, here's the top. So I'm going to roll it, and we're going to just kind of keep track of, did I get the number 4 or did I not get the number 4? So as I roll, how about I do a tally of the times that I get the number 4 and the times that I do not get the number 4. Okay? So, let's see. I want to see if I can actually make this big so you guys can watch it. Sure, we'll go with that. Okay, we're going to go ahead and roll this dice. Maybe I'll throw it in the air. I don't know how well that's going to work. And I got a 6. So we can just go ahead and tally that I got a 6. So it's not a 4. Okay, I'm going to leave the video small. That'll just be easier for me. Throw it in the air again. I got a 6 again. That's not a 4. Throw it in the air again. I promise you guys, I am rolling this thing. I'm throwing it in the air. Here, maybe I can show you guys, like, I'm throwing it in the air. Oh, well, now we didn't get a 6 anymore. Okay, it's still not a 4. How many times should we do this? We could do this like 20 times. It's not a 4. It's not a 4. It's not a 4. It's not a 4, although this thing sure likes those certain numbers, huh? Still not a 4. Ooh, we got a 4! Yay, yes. It's not a 4. It's not a 4. It's not a 4. If we were in class, you guys would be the one rolling this, so sorry, you guys just have to watch me do it. Still not a 4. We'll go a few more times. Oh, we got a 4. It's not a 4. Okay, let's see. 3 more times. Looks like that should be 20. It's not a 4. It's not a 4. Come on, 4. Nope. Still not a 4. Okay, so we rolled it a total of 20 times. And we, thought in theory, our theoretical probability was that 1 in 6 should have been the amount of times that we got the number 4. Let's figure out what's our reality and see how close they were to each other. So in reality, I'm going to make my part and my total. And when I say reality, I should say experimental. My experiment, the experiment I just did with my ginormous, see, it's like bigger than my head, with my ginormous dice, or my die, what's the correct word, is in total, I rolled that 20 times. I rolled that dice 20 times. And two of those times, I got the number that I wanted. So this was my experimental probability. Let's go ahead and change these both into percents to find out what percent of the time we thought we should have gotten it compared to what percent of the time we actually got it. So I'm just going to use my calculator on my phone. If you have a regular calculator, that's great, or a phone calculator or Google, those work great too. I just do top divided by bottom. So 1 divided by 6, I think it gives me a long one. That rounds, I'm just going to round it to 17%. And let's do this. 2 divided by 20. 2 divided by 20 equals 0.1. 0.1, we have to move that decimal 2 spaces, so it is 10%. So our experimental probability was actually lower than our theoretical probability.